In this chapter, we're going to think about technology and costs. So when we think about the structure of an industry, it's important to think not just about the number of firms and the size of those firms, but also to think about the technology that the firms use to produce the goods that they're producing, and how that technology manifests itself in the production costs for the firm. Because the nature of production costs can have important impacts on how an industry functions and the structure of that industry. So a firm uses inputs to make output. Technology governs the physical process that the firm uses to convert those inputs into output. The objective of a firm we've talked about before, and you would have seen in many other classes, the objective of a firm is to maximize profit. But in order to maximize profit, you have to first minimize cost. So minimizing cost is a necessary condition for maximizing profit. It's not a sufficient condition. What that means is that you can't be maximizing profit unless you're minimizing costs. That's necessary. But just because you're minimizing costs does not mean that you're maximizing profit. You could be choosing the wrong quantity to produce, or you could be choosing the wrong price to sell it at. And this is a very neoclassical view of how a firm operates. It ignores a lot of stuff that happens within a firm. So a lot of times we talk in economics about markets, and there's a big emphasis placed on how markets work, and justifiably, that's important. But when you think about how a firm works, the interior structure of how a firm operates is not based on markets. Firms oftentimes operate very undemocratically. You have people making decisions and other people that have to do what those decision makers say they should do. So there's the owner-manager relationship and whether or not the incentives of the manager match up with the incentives of the owner. There's and that doesn't have anything to do with market forces. There's the relationship between the manager and the worker. There's the relationship between the firm and the customer. And those take place in the context of markets, but how they themselves function is not based on markets. And there's a lot of issues that you would need to discuss if you really want to understand how a firm functions. There's contracting within the firm and how the firm contracts with other firms, and implicit contracts that the firm may make with its customers. There's information asymmetry, so there's a different amount of information between the workers and the decision makers, and between the firm and the customers, and maybe between the government and the firm. There's incentive compatibility, so are the incentives of the decision makers lining up with the incentives of the workers? There are a lot of issues that are beyond the scope of this class. And you could spend your whole life devoting yourself to understanding the nature of how firms function. We're going to step back away from that, and we're going to first just kind of review some stuff that we know about costs. We're going to focus on technology and the conversion of inputs into outputs and what that means in terms of the costs of production for the firm. So if we think about a firm's production function, we could write that production function very generally as output Q equal to some function of a bunch of inputs. So this could be, say, X1, X2, up to, say, XK. So this says that output here, Q, is some function of the variety of inputs that we're using. If we think about W's to represent input prices, so say if we're thinking input prices, we could have W1, that would be the price of a unit of input X1, and we could have W2 up to WK. So there are our inputs. And if we think about the cost of production, then the cost of production would be the sum over 1 to K of the price times the amount of the input that the firm uses. So it would be the sum where I runs from 1 to K of WI XI. That would be the cost of production for the firm. And that simply looks like this. It would be W1 X1 plus W2 X2 plus WK XK. And the firm seeks to minimize that cost of production. So the objective, the goal of the firm is to minimize this. In other words, choose, given the input prices, which the firm's going to have no control over, but given the input prices, choose the quantity of X1, X2, up to XK that minimizes the cost of producing a particular level of output. So it's going to minimize the cost subject to, minimize cost of production, but it's got a constraint. I'm going to say subject to the constraint, which is this, subject to the production technology that it uses. I'm going to say Q bar just to represent a particular level of Q. Q bar is equal to that production function that has as its arguments the inputs. So minimize the cost of production subject to the technology that it uses, right there. And if you need some more information, you want to refresh your memory on that, you can go to my intermediate microeconomics videos and look for production technology, cost of production, the producer's decision, and you'll see that cost minimization process worked out. It involves thinking about some isoquants and some isocost lines. It's relatively straightforward. So we're not going to review that here. What comes out of that, if we solve that problem, the result of that, what we get from that is the cost function. And different textbooks use different way, write the cost function differently. A lot of times I might write it as let's say the total cost of producing any level of output is equal to F plus C of Q, where F here is just our fixed cost and this would be our variable cost. This is not a function of Q. That part is. Obviously, that's what makes that the fixed cost, and that's our variable cost. Sometimes you see this without the T. Sometimes you see it as just C of Q, cost function. A lot of times I just write it as this. Total cost is equal to fixed cost plus variable cost. That's a more general way of writing it. So your fixed cost could be things like the rent that you have to pay for your building, or the foregone rent if you own the building. That would be a fixed cost. Or advertising that you do. That doesn't depend on the quantity of output that you produce. And then your variable cost is going to be things like raw materials and labor and other inputs, electricity, things like that. There are some measures of cost that we find very useful. So we can think about average total cost. That's just equal to total cost divided by Q. Here I've used little q, so maybe I should stick with that. Total cost divided by little q, the output of the firm. We could think about average fixed cost. That's just equal to fixed cost divided by Q. Average variable cost, that's equal to variable cost divided by Q. We can take this and we can convert it to averages, we get that average total cost is equal to average fixed cost plus average variable cost. So all of those are things that you already know from studying the costs of production. Marginal cost is arguably the most important cost measure that we think about. And marginal cost is just the change in total cost when you change quantity by a unit. So we could think about that as the change in total cost when you change output. Usually we're thinking about a 1 unit change in output. If we were to think about, say, a quick example of that, we could have a total cost curve that looks something like this. Total cost as a function of quantity is equal to, say, 500 plus 20Q plus 2Q squared. There's a straightforward cost function. This part of it would be your fixed cost because it doesn't involve a Q. This part of it out here would be your variable cost because clearly there are Q's involved in that. I'm going to draw a little line like that so we can distinguish. So if we were to think about marginal cost, then if we took the derivative of that with respect to Q, and if you don't know how to do that, don't worry about it. I would give you the marginal cost curve. But if you took the derivative of that with respect to Q, then you get marginal cost, and that's equal to 20 plus 4Q. There's the marginal cost that would go with that total cost curve. We need to briefly think about sunk costs. So for a firm or for anybody, a sunk cost is a cost that has already been committed and cannot be recovered no matter what you do. It's very different from an opportunity cost. An opportunity cost is a cost where the magnitude of the cost depends on the choice that you make. But a sunk cost, that's already been committed. We think about what I'm going to refer to as kind of the typical cost curves. We've already looked at them in this class, and you would have seen them in a Principles of Microeconomics class, an intermediate micro class. You would have seen it in any class where you do any type of discussion about the way markets work. But the typical cost curves, we're going to have a marginal cost. Usually I don't put the little curved part on my marginal cost if I'm working through it. You already know that part of the marginal cost curve is irrelevant. It doesn't matter. We've got an average total cost curve, and we've got an average variable cost curve. Those are our typical cost curves. Usually we would put price or maybe dollars up there. Here's Q. We don't have average fixed cost on the picture, but remember, average fixed cost is that vertical distance between the average total cost and the average variable cost curve, right? Here's average total cost. That curve right there is equal to average variable cost plus average fixed cost. Well, right there's average variable cost, so that height is average variable cost plus average fixed cost. And that's why this average fixed cost, the distance between these curves is getting closer and closer, because as you increase Q, average fixed cost is going to 0. Remember, that numerator is fixed, so as we increase the denominator, that thing is getting asymptotically close to the horizontal axis. Remember that all firms maximize profit by producing the quantity where marginal cost equals marginal revenue. That's the first equal marginal principle applied to profit maximization. We need to review the shutdown and the entry-exit conditions. So if we think about the shutdown condition, remember, shutdown is a short-run situation where the firm just chooses to produce no output, and the firm will shut down if price falls below average variable cost. what that means is if they can't make enough revenue to cover their variable costs, then it's not worth bringing your workers in and producing because you're going to lose your fixed cost and you're going to lose part of your variable cost. So in that case, you just shut down. If your revenue is big enough to cover all of your variable cost, then that means your price is greater than average variable cost. And then you're going to be able to cover that variable cost and part of your fixed cost. So you would produce in that case. The entry-exit condition, entry-exit, this one's straightforward. This is just you exit, let's say it this way, exit if price falls below average total cost. This just means profit is negative. In the long run, a firm will exit if profit is negative. In the long run, firms will enter a market if profit is positive. So if I were to put the shutdown and the entry-exit points on this picture, our entry-exit point would be right here. This would be entry, exit, and then right here at the bottom of that average variable cost curve, that's your shutdown point. If price is up here, then the firm's going to produce and profit's going to be positive. If price falls below this point down here, profit's going to be negative. But if price is in this range, even though profit is negative, the firm is still going to produce because it loses less by producing than it would if it shut down. But if price falls down here, then the firm is going to shut down. It just produces nothing. Let's review the relationship between our marginal cost curve and our average total cost. So I'm going to draw another picture where I have just those two curves. So I've got marginal cost, got average total cost. Right there's the point at which those two intersect. That's the bottom of the average total cost curve. If you look over in this range, and we always think about moving from left to right, so from here over here. If we think about what's going on here, then what we see is that marginal cost is less than average total cost. Marginal cost less than average total cost in this range. And then over here we see that marginal cost is greater than average total cost. So again, as we think about moving in this direction, while we're in the range where marginal cost is less than average total cost, what we see is that average total cost is going down, it's falling. Average total cost falling. And then we get over into this range and marginal cost is greater than average total cost. We see that average total cost is rising. And at the place where marginal cost and average total cost are equal to each other, average total cost is at a minimum. And that's just a property of the relationship between average measures and marginal measures. If we think about costs in the short run and the long run, if we're thinking about the long run, then remember the long run is when the firm has no fixed input. Another way of thinking about it is the long run is when the firm has no fixed costs, but fixed costs come from a fixed input, so they mean the same thing. A lot of times when we're drawing a picture of the long run, we stretch out the horizontal axis a little bit more because the long run is when the firm has no plant already built or no amount of capital that it's chosen. And so when we think about the average total cost, long run average total cost, we usually think about it as being a wider curve than the short run average total cost. So I'm going to just call this average cost here. But we're thinking about that as a long run average total cost. If we think about, again, starting over here and moving to the right, what we see is average total cost is falling up to somewhere right around in here. And then it stays constant, and then it starts to go back up somewhere right around in here. And we've got some names for different areas here. We would say that the firm is experiencing economies of scale here and diseconomies of scale here. And then constant returns to scale right there. If we think about the causes of economies of scale and diseconomies of scale, let's start with economies. Really what's happening here is that as the firm increases the scale of its operation, that allows for its workers to specialize. And when the workers specialize, then they get better, they get more productive at the task that they're doing. So that's one thing that can cause economies of scale. It could also be that economies of scale are caused by the presence of large fixed costs when a firm wants to enter the market. So if entering the market entails a big outlay of fixed costs, then that's going to lead to economies of scale. This is really where natural monopolies come from. So if we're thinking about, say, delivering water to houses, well, if we're going to deliver water to houses through pipes, that requires a network of pipes. And so any firm that wanted to enter that market would have to lay its own network of pipes to every house in town, and that would require a huge outlay, a big fixed cost that as the firm produces more, then that spreads that big fixed cost over a larger quantity. So that's where economies of scale come from. Diseconomies of scale come from the fact that very large production processes are just hard to manage. You have to have extra layers of managers, and the managers aren't producing output, they're simply managing the workers. So if we want to think about measuring scale economies, we can think about the relationship. I don't have a long-run marginal cost on here, but we could think about something like that, or we could refer to this. You could think about whether or not we're in this portion or this portion of that picture by looking at the relationship between average total cost and marginal cost, and we can define something that we call S, and S is going to be a measure of scale economies. It's simply average total cost divided by marginal cost. I'm going to do a bit of algebra here. I'm going to write my average total cost using that notation down there. This would be your variable cost plus your fixed cost divided by Q over marginal cost. And then I can rewrite that this way. This is just variable cost plus fixed cost divided by Q times marginal cost, which I'm going to remind ourselves marginal cost is a function of Q. So that's S. The more S exceeds 1, the bigger the scale economies. So right here, average total cost and marginal cost are equal. So that S would be equal to 1 right here. But as we move over in this direction, average total cost is getting bigger and bigger compared to marginal cost. And so S would be getting bigger there. And there would be even bigger economies of scale over here. We can think about the minimum efficient scale. That's the lowest level of output for which S equals 1. And that would be right here. In this picture, that would be your minimum efficient scale. As long as there are scale economies, then there will be an incentive for firms to consolidate. So if we have an industry that's over here in this range of output, then there's going to be an incentive for firms to consolidate. That incentive, that economy of scale, means that getting bigger gives you a benefit. one firm could produce a particular amount of output cheaper than multiple firms could produce the same amount of output. And the way that we could think about that is this. If I were just thinking about this portion of the average total cost curve, and we thought about a firm producing Q, and we looked at the cost on average of producing Q for one firm, we would see that it's somewhere right there. There's average total cost. On average, that's the cost of producing I need to move right over here. So right here's the average total cost. If instead of one firm producing Q, let's suppose we had two firms, each producing half of that, then each firm would be producing Q over 2. And the problem would be that each firm would now have a higher average total cost. So one firm can produce the amount cheaper than two firms where the sum of what the two firms are producing is equal to what the one firm produced. You can have scale economies exist over the entire range of output, or you could have scale economies exist over what we call the relevant range of output. So you could have an average total cost curve that looks like this, but if the total amount of output that needs to be produced in the entire industry is somewhere less than or equal to that amount, then there are scale economies over the relevant range of output. And when you have scale economies, what you tend to have is concentrated markets. You tend to have a small number of firms, each with large shares of the market. What I need to do is clear this off, and then we're going to talk about the impact that sunk cost has on industry structure. Let's think for a second about the impact that sunk cost can have on industry structure. So remember that entry only takes place if profit is positive. But consider the situation if entry requires a big outlay of cost for the firm that's going to be a sunk cost, like I was just discussing. Well, if that's the case, then you're going to have a long-run equilibrium where profit is positive and just big enough to cover that sunk cost. Otherwise, firms would not incur the sunk cost to enter. If they incurred the sunk cost, or let's say if once they get in, their profit is 0, then that means that they can't get back that cost they're going to incur when they enter the market. So that would be another way to think of long-run equilibrium if there's a big sunk cost. The profit's going to have to be just enough to cover that sunk cost. If we think about firms that produce multiple goods, that's a much more realistic view of what most firms do. So very few firms produce only one thing. What we need to do is we need to think about some measures of average cost and measures maybe of scale economies for multi-product firms. So if we think about economies of scope, then what we're thinking about is scale has to do with the size of the manufacturing process. Scope has to do with producing more than one good. So if we think about a firm that produces two goods, maybe Q1 and Q2, then we can generalize the cost function to account for now the fact that there's an additional output. So we could think about the total cost of producing Q1 and Q2, and that's going to be the fixed cost plus the variable cost of producing Q1 and Q2. So that's a more general cost function. Scope economies exist. We would say that scope economies exist if the cost of producing each good separately is higher than the cost of producing them together. So we would say that let's write the cost of producing them separately first. So if we had the variable cost of producing just Q1 by itself, no Q2, plus we're going to incur a fixed cost associated with that, and then add to that the cost of producing just Q2. So now we have 0 Q1 and just Q2, but there's going to be a fixed cost associated with that. So if we're now producing Q1 in its own separate facility and we're producing Q2 in its own separate facility, we would say that economies of scope exist if that is greater than the cost of producing them together. Q1, Q2 plus F. And we can define a measure that we call scope. Scope, sometimes we call it scope economies, but usually we abbreviate it SC. And here's what that looks like. I need to fit this all on one. So I'm going to take this chunk right here, and I'm going to subtract off that. That's going to be my numerator, so I'm going to write it this way. C Q1 F1 plus F2 minus the cost of producing them together. Q1, Q2 plus F. I'm going to put that in parentheses. And then we're going to divide by that. So this is the difference in cost from producing them separately and producing them together, divided by the cost of producing them together. Economies of scope exist if SC is greater than 0. So economies of scope if this thing is greater than 0. That simply means that the cost of producing them separately is greater than the cost of producing them together. Let's talk about why economies of scope might exist. And there are a variety of things that could cause it to be cheaper to produce the two goods together rather than separately. And that could be that they share a common input or common inputs. So maybe that creates some cost benefit to producing them together. It could be that there are cost complementarities. So maybe the production of one good makes it cheaper to produce the other good in the same place. So an example of that might be maybe a firm that produces, say, computer operating systems might find it cheaper to also offer computer consulting services. Maybe there's something about that, having the people in one location that allows them to do that cheaper than if they had two separate facilities to do it. And the reason that this is important is that economies of scope, the presence of economies of scope, can lead to more concentrated industries. Because if there are economies of scope across products, then you will have fewer firms because you'll have firms producing multiple products. So firms may consolidate across product lines. Another thing that we need to consider is learning by doing. That's something that can impact industry structure. And what we mean by learning by doing is, say, learning by doing. What this simply means is that we're talking about the firm's cumulative output over its entire history. So how much output has the firm produced up to this point? the more a firm is produced up to a particular point, the more concentrated an industry can be, because it provides an advantage to the firms that were there at the beginning, the early entrants into the industry. Another thing that we need to think about is that learning by doing can give firms an incentive to price artificially low. And you might wonder, well, why might they sell the good at a price lower than they are capable of selling it at? Why would you do that? Well, there could be a couple of benefits. One is that you're going to produce more, which is going to allow you to learn more. It accumulates more, you accumulate more learning. Another thing to think about is that might also deprive other firms of the ability to produce as much, which deprives them from learning by doing. So firms can learn by producing more, but firms can also forget. So you might have a firm that wants to, let's say there is some forgetting. You might have a firm that prices artificially low so that they can produce more, so that they can learn more to offset some of the forgetting that's happening. Maybe people are leaving the firm over time, and those people are important. And so what needs to happen is that the people who are going to remain need to produce a lot to offset the people who are leaving with the information that they have. So learning by doing is an important aspect of the concentration in an industry. We can think about a number of non-cost determinants of industry structure. So things that don't have to do with costs that also determine the structure of an industry might be the market size. So how big is the market? A way to think about this might be that a small community might support maybe only one dentist in town. But as the community gets bigger, then there are more customers that could support more dentists moving into that particular market. And that doesn't have anything to do with the costs or the technology of providing dental services. It has more to do with the size of the market that we're talking about. We can also think about network externalities. Network externalities. This is a situation where the size of the network impacts consumer willingness to pay. So there are some services usually that are provided where the magnitude of the network makes it more or less usable. Kind of the classic example would be a dating service. So a dating service gets more useful the bigger it is, because the bigger it is, the more people who are involved in that network. If you have a dating service that only has, say, 20 people in it, that's probably not going to be a very useful. If you were thinking about joining a dating service, then that would be something that you would probably pass on. We can also think about government policy. So government policy can have very important impacts on how concentrated a market is. So let's say an example of that might be in lots of markets, taxi cabs have to have a license or a medallion to operate. And so if the government refuses to issue new medallions, then there's not going to be any entry into that market, and it doesn't have anything to do with the cost of driving a taxi cab in that particular market. It has to do with government policy. So this happens in a lot of markets where there's licensing requirements. That requirement itself can be an important determinant of how concentrated the market is. I'll see you in another video.